Hello, it's warm welcome to you. I am Nikesh. In today's video, we'll create our own class of linear regression. So if you talked about the linear regression, the core of the function of the linear regression is to find the best fit line. And to find the best fit line, you have to find the value of intercept and coefficient. And to find the value of intercept and coefficient, there is two ways. First is OLS and second is gradient descent. In OLS stand for ordinary least square. There is a direct formula. We can easily find the value of intercept and coefficient. And the second was gradient descent. So if you talked about the gradient descent also divided into three types based on the implementation of a means technique of implementation of a gradient descent. The first one is page gradient descent, and the second one is stochastic gradient descent, and the third one is mini batch gradient descent. So in this video, I am going to use batch gradient descent to create our machine learning model of linear regression. So let's see how to create our own class of linear regression. So class class word keyword is used whenever we have to define our class and also the name. So in my case it is batch gradient descent regressor. BGDR stand for the batch gradient descent regressor, and creating okay, I'm creating a constructor. So def keyword required, and in it inside this I have to provide a self. Later I will explain why I'm providing self here. And in gradient descent we need epoch, and another is learning rate. So epoch is used to iteration again and again, and learning rate is used to control the step size of a gradient descent. Later I will explain this better way. So let's write for this. First I have to define epoch. Its by default value is I'm giving 100, and learning rate is I'm going to use LR, yeah, okay, is 0.05. Okay, and now I'm creating a variable to store the value. So for that variable, so first is my self dot learning rate is equal to LR. At the time of creating the object of our model, we provide the value. The same value will be stored in this variable. Okay, and the second one is for self dot epoch. It is also we have to provide at time of creating an object. It is also same epoch. And I have already told you that in linear regression we have to find the value of intercept and the coefficient. So I have to create a variable for intercept and coefficient, which is also known as slope. So intercept and slope. So here self dot slope. The beginning I'm creating a empty empty variable. Okay, and same for intercept. It's known. Now I have to write a code to train our machine learning model based on our training data sets. Okay, so it is my fit name of my method, and also have to provide a self, and we train our machine learning model based on our training data. And training data also we divided into X train and Y train, and some data we store for test. So to train our model we have to provide training data. So it is first X train and Y train. Based on this data we have to create our we have to train our model. So now I am going to first giving the value of intercept and slope to begin the gradient descent with a some number. Okay, so slope is equal, sorry, I have to write self dot intercept. By default I am giving 0. Okay, intercept is a single scalar value, so we start with the value of 0, but the slope is not a single value, means scalar value. I mean to say that if there are 5 or 6 features in our training data, means if there are more than one column in our training data, then we have to provide the value for each features. Okay, so we can start our gradient with some random number. So first I have to give, so I am going to give one value for each features. Let's see how to do that. Self dot slope is equal to np dot ones. Okay, from this I am able to give one for each features. So how I can know that how many features in our data? It is very simple. We just have to use extend dot shape of 1. From this line of code we can easily get the number of the column, and on each column we providing 1. Okay, for the slope value. So now I'm going to apply gradient descent. So here I have to run a loop, because gradient descent is repetitive function. For I in range of how many time I want to run a loop, it is self dot epoch. If I am at the time of creating an object of our model, if I give 100, then this loop run hundreds time. Okay, and inside this I have to find the y hat, which is also known as a predicted based on our training data. Okay, this time we have to find the predicted value on training data. Y hat is equal to, so to find the training data we have to, the formula is xtrain dot product of, this symbol is also used to do the dot product, and self dot slope. Okay, it is a random number now, which I provided one, means for if there are multiple features, then the slope value of each features is 1. Okay, and also I have to plus self dot intercept. Okay, this is done now. Now I'm going to find the derivative of intercept. Derivative of intercept. So let's see. The formula is simple. -2 into, it is a scalar value, so we have to find the mean. Okay, let's see how to do that. Actual minus y-train. Y-train is our training data, minus y hat. Okay. Okay, from this I can get, okay, I have to find the mean into np dot mean. Okay, now I am going to find the derivative of slope. It is, the formula is -2 into np dot product of this time I need y train. It is a training data, y train minus y hat. Let's put it inside this bracket. Okay, so by subtracting y train minus y hat, I am get value, and I have to dot product with it x train. xtrain, and whole this divided by total number of row present in our training data. So how we can get the total number of rows? It's also simple. Xtrain dot save of save 0. From this code we get the all number of row and whole divided by this. So I am completed derivative parts. Now I am going to apply gradient descent. The formula of the gradient descent is old value minus new value. Okay, this is the simple way, but let's see how to solve. Self dot intercept is equal to self dot old value minus new value, but I am going to write LR means learning rate with our derivative intercept. Okay, so self dot learning rate is required to control the step size in gradient. Okay, so it is completed now, and now this time I have to find the slope. Self dot slope is self dot slope old value minus new value. Again I have to write as learning rate to control our step size width into width t of slope. It is done now. Now I am going to write a code to predict our data. Predict. So def predict. Okay, and we predict we predict based on our test data. So in my case it is x test. So let's see how to write self dot self, and this time I have to write test data. Okay, and it is done now. Simply I have to return. The formula to predict is simply x dot product of x test into slope, and we have to add intercept. So np dot product of x test to self dot slope plus self dot intercept. Okay, so let's me run this code. I have already run this code, and to test our model I have already created a dummy data sets. So here you can see from sklearn model selection I have import my training test split class to divide our data into training and test. And from sklearn the matrix I used R2 score to find the accuracy of our model. So here is a code to create a dummy data sets, and here I have divided my data into x train, x test, y train, y test, and here I have provided. So I am creating a model means our object name model. I am calling my model BGDR, and I am giving epoch value 100 1000. This time learning rate is 0.05, and I am calling my fit method, and providing x train and y train means our training data. And after training our model I am again calling my predicted prediction. Okay, now I have to change predict. Okay, in my case is predict, so I have to write here predict. Oh, I'm sorry, predict. Okay, if I run this code, is some error self. Oh, sorry, there is a spelling mistake. Hmm, yes, elf self. Again, I have to create a class, and now if I run this, so now we can see that our model learning, these are our coefficient slope value is 2 minus 191.48. Okay, and our intercept value is 4.95. So this is our first predicted value, and our R2 score is 0.99. It is very good, and you can say if there is 99, we can say that our model is overfit. Okay, so this is the way to create our own class of linear regression with the help of base gradient descent. The disadvantage of this base gradient descent is that if the data is too high, then we can't train our model, because suppose if our x train is in GB, means if it is in GB or in too many data, then we can't train our model, because you have to load all data at a time in our RAM. So on on that type of situation, we our memory error raised, and we can't train our model. So to avoid this problem, there is another way of implementation of a gradient descent is stochastic gradient descent. In next video, I will show you how to create our own class of linear regression with the help of stochastic gradient descent. Thank you for watching this video.